You're here for the new Lowell images of 3I/Atlas. You're in the right place. 3 minutes ago, Arizona snapped a bright point with a faint glow, no dense dust tail. Yet this thing is speeding up without gravity doing the work.
We've got some updates. Check out these new images that show 3I/Atlas in a whole new light. What's going on with this situation? What are these jets? So how did the object go from an anti-tail to a tail to a no tail to an anti-tail to whatever it is that we are now seeing? Is it streaming out? What is all this? Is it breaking up after possibly going behind our sun? A little confusing because this all comes after last week images showed the object with no tail. Weird.
Think of a boat gunning it but leaving no wake. Today I'll show you why that's a paradox, how the required gas loss would be massive, billions of tons, and why we don't see the cloud. Stay with me, and by the end, you'll know the test that decides natural outgassing versus propulsion. Before we move on, I'd like to ask you a small favor. If you appreciate this content, please take a second to like this video and subscribe to the channel. Over 98% of you watch the videos without subscribing. It costs you nothing, but it makes a huge difference to us. So, did you click the subscribe button? Great! Thank you so much. Now, back to the video. A fast boat with no wake. That's what these new Lowell frames hand us. 3I/Atlas ramping up, yet the sensor catches a tight core with only a faint haze around it.
Well, thanks for having me. We see more than 7 jets that are tightly collimated coming out of this object. And of course, there are 2 possibilities that we considered all along. And so how do we tell the difference? Well, if it's a natural object, then we know the temperature on the surface of a rock, given its distance from the sun. And these jets are naturally produced out of ice on the surface of a rock. And the second possibility is that they might be thrusters on the technological spacecraft.
Not the heavy tail you expect when stuff is flying off in bulk. Let's lay out what the camera actually saw. In blue light, the point pops. In green, it drops. The coma is there but thin, a soft shell, and the field is clean with steady air, so blur isn't hiding a tail. No thick dust streamer leaning away, just a crisp dot and a light fog. Here's the rub. If gravity isn't doing the work, something else is. Comet physics says that's gas and dust venting. Push needs exhaust. And lots of exhaust makes a big, lit cloud.
Even after it passed through perihelion, it was heated by 770 watts per square meter. And we know that the previous plume of gas was mostly carbon dioxide by the solar radiation and the solar wind. But we don't see that. So the question is, what's going on? One possibility is that what evaporates from it are fragments of ice, and they get vaporized by sunlight. And carbon dioxide ices can sublimate at a much lower temperature than water ice. So we should have seen it break up, or at the very least disintegrate to a very dense and massive cloud of gas and dust that is pushed away from the sun.
So let's speak plain on non-gravitational acceleration. Jets act like tiny thrusters. They kick off mass and nudge the body the other way. More push means more outflow. Scale it up to match the measured speed up and you're in the realm of huge release over weeks. Now bring it back to the sea. When a trawler hauls at full speed, the wake boils and spreads. You read the churn from far off. Here, the churn is missing. The color adds another twist. The green filter tags carbon bands that flare when gas is rich. It's not bright there. The blue stays strong. Dust, when thick, tends to redden the light, not skew it blue. So the mix looks off for a dust-heavy plume. Other ground stacks picked up tangled jets and a broad halo in some views, which hints at structure. Yet this clean Lowell snapshot, with good seeing and reach, still shows no fat, dusty tail where it should stand out best. So today's frames sharpen the puzzle. Strong reported push. Thin coma. No dense tail in the cleanest look. That gap matters. Next up, we put hard numbers against that scene and ask a simple thing. If the thrust needs a flood of gas, where's the cloud?
Before they have a chance to turn around and show up as a plume of glow behind it, away from the sun. That's one possible interpretation, but otherwise I just don't know what to make of it. So what I'm saying is, there are things we don't fully understand about this object. That's what makes it exciting, and I think all of us will wait for the data that will come in the coming weeks. There was also a blue color that was noticed just a few days ago, and also, in addition to that, it became brighter by a factor of 5.
And what does that say about outgassing versus a different kind of push? If the thrust is real, the exhaust should be massive. So where's the cloud? Let's convert push into flow. To get that steady speed up, you need gas streaming off non-stop. Think of thrust as force per time. To match it, mass must leave fast enough and in one direction long enough to matter. That means a heavy release, not a few puffs, and it should light up the scene around the core. That load of gas and dust leaves 3 marks. First, a thick dust tail that stays in frame even with short exposures. Second, strong carbon and OH lines that flare in green-sensitive views and in radio. Third, a rise in brightness that tracks the playbook for active comets. Now check what we have. The Lowell frame shows no dense tail stitched to the point. The green filter isn't flaring like a carbon-rich blaze. Blue stays high and clean. If dust ruled, you'd expect a warmer tone and a smeared fan. We don't see it. There is chemistry in the mix. Radio work near the sun picked up OH, which flags water breakup. So some gas is there. But the amount looks small for the push on the table. If that flow were big enough to drive the motion, it should blanket the scene. Here's a twist that adds strain. Jet geometry points toward the sun in some stacks, with hints of an anti-tail shape from dust lined up in the orbital plane. That's odd if solar heat alone steers all vents, since the net push would tilt away, not show a tidy point with scant haze. Photometry adds more outliers, a very steep brightening index near -7.5, a blue skew at perihelion, and polarization reports that don't match the usual dust mix. Put it on one chart in your head. Acceleration goes up. Classic coma signs go down. Those lines don't meet. So if the gas cannot pay the bill for the push, propulsion stays in play as a live hypothesis. Next up, the close approach window. Watch for a large, obvious gas cloud. If it doesn't show, the paradox holds. A fast object with no wake changes the question. Stop asking how much gas. Ask what's doing the pushing. Watch the December window. That's the close pass, the clean test. If a giant cloud shows up, the case leans toward outgassing. If it doesn't, expect sharper debate. Subscribe and come back for the verdict. Next time, we'll go straight into the tools. One Hubble filter can isolate gas bands. One JWST setting can map heat and grains. The trick is simple. Use narrow slices of light to tag what's real thrust and what's glare. You'll see how a single pass can settle the push.